So this question tests your ability to factor quadratic expressions of this form with two variables. And the factorization is very similar to what you would do with quadratic equations. So I'm just going to start with choice A. And what you do is you look at the products of the first and last term. That's 12x squared y squared with minus. So you have to split the middle term into two terms that would give you this product. And so that would be, you need a difference of minus 1, two numbers that multiply to give you minus 12. So those are going to be minus 4 and minus 3. So the terms would be minus 4xy plus 3xy. So all you're doing is replacing the middle term with that new split. And then you factor it in pairs. So this is generally what I would always do with factoring quadratic equations, especially when there is a coefficient for the first term. So here factor the largest common term, 2x. So that would be x minus 2y. And then here I factor 3y, x minus 2y. Then you factor this piece out. So you'll see that this isn't the answer choice because 2x plus 3y is a factor, but not 2x minus 3y. So this is a harder question because you don't know which one of these would be true, so you'd have to do a little bit of a trial and error. We do B, which has a very similar structure. The difference is that this sign would be flipped. And then the next step is the same. So that would be x plus 2y, and here would be minus 3y. And now you would see that 2x minus 3y is indeed a factor. So the answer is B. And of course, depending on where you start in your choices, you may have to struggle with these others as well. And that's just how these types of questions, which are which of the following, you don't know which one is correct. So that's a little bit of a trial and error. So that's one approach. The second approach is by plugging in numbers. And the way to think about that is that if, let's say, this is the correct answer, that means it should factor into 2x minus 3y times some other term. Now, these two expressions, if they are identical, would be true for all values of x and y. So I can pick a values for x and y, which makes this term 0, so that this entire product would be 0, meaning it doesn't really matter what that other piece would be. So for example, if I choose x is 3, y is 2, then this would be 6 minus 6 is 0. This entire product would be 0 because it doesn't matter whether this is 0 or non-zero, since this piece is 0. So all I have to do is to plug in these values into that expression and see, does it also come out to be 0? So that's what I'm going to do. And we'll compute this out. So that's 18 minus 6 minus 24, and this is minus 12, which is not equal to 0, which means this isn't the correct answer. So I'll do the same thing for choice B. You'll notice it's just the middle term is now plus. And so this is 18 plus 6 minus 24. That's 24 minus 24 is 0. So that one works. Now, whenever you're plugging in values, just make sure you test all of them, because it's just have to make sure that that particular example you pick is able to differentiate. So 2, 3 square minus 3, 2 plus 3 times 2 square. So 18 minus 6 plus 12, that is 24, again not 0. And then D would be, the only thing is that these signs are flipped. So 18 plus 6 minus 12, which is 12, which is not equal to 0. So that eliminates that as well. So the answer is B. So this is how the plug-in approach would work, where I've chosen values so that this expression becomes 0, so that I don't need to know what the other part is in the factorization, and I can test if that piece also matches to 0. So you can take either approach. The factorization, you definitely need to know how to do it. And to recap, the answer is B.